Okay, a common mistake is when you're multiplying something like this, people try to multiply the 13s, but 13 is the base, and the base never changes. All you do is you add the exponents. So this is going to be 13 to the 4 plus 8, which is 12th power. Now, if you wanted to evaluate that, you'd have to go 13 times 13, 12 times. It's going to get some outrageously large numbers. So we'll leave this in exponential form. Okay, now we have 8 is the base, and this is like 8 to the 9 times 8 to the 1. So remember, the base stays the same, and you just add the exponents. So this is 8 to the 10th power. And again, we're going to leave that in exponential form. So here our base is x. So remember, just like this, your base doesn't change. So it's still x, but it's going to be, we're going to add the exponents when we're multiplying. Oops. So we're going to get x to the 17th power. Now, the reason you're multiplying the -3 and the 9 is because they're not bases. There's no exponent up on these. So we do multiply -3 times 9 to get -27. The w's are bases because they have exponents. So the w stays the same, and all you do when you're multiplying is you add the exponents. 5 plus 3 is 8. So that's going to be like that. Okay, again, we're multiplying here. So we're multiplying the 2 and the 9 because they're not bases. Those are called coefficients. So we're multiplying those coefficients. 2 times 9 is 18. And then we're going to take the x, and we have a 2 here and a 1 here. 2 plus 1 is 3. And then we have the y as a base because they have exponents. And 5 here and 3 here give us 5 plus 3 is 8. And that's the final answer there. Okay, this is the answer. We cannot simplify this further. We can get rid of that multiplication symbol. But the reason we can't do anything here is these are two entirely different bases, so we cannot add those exponents. We just stick it together like this. Okay, a common mistake is to think that this is 0, but anything to the 0 power, any non-zero number to the 0 power is 1. So it doesn't matter what the base is. When you take it to the 0 power, it's just equal to 1. This right here is equal to 1, but then you tack on the negative, so you end up with -1. This is going to be a positive one because remember, it doesn't matter what the base is. The base, negative or positive, it doesn't make a difference. But because that negative is within this and that's all part of the base, this answer is just a +1. Okay, now this right here, just this part is a 1. And then you tack this on and you get -1 minus, and this entire thing is 1. Because anything to the 0 power is 1. So now we have -1 minus 1. This is -2. Okay, a negative exponent, that's an inverse. And so what we're going to do is you think of this as like 5 over 1, and then the inverse means we're going to make it a positive exponent by putting it to the other side of the fraction. So that's going to be 5 to the +4 down there. And we're going to leave behind a 1 because 1 is a factor of everything. So we want to write this with positive exponents, so I can leave this in exponent form. If you wanted to completely evaluate it, you'd have to figure out what 5 to the 4 is. 5 to the 2nd is 25 times another 5, so 5 to the 3rd is 125 times another 5, so 5 to the 4 is 625. So this would have been 1 over 625. All right. Negative exponent means we bring this in and we have 4 to the -2, x to the -2. So we bring this down to the other side of the fraction and we get 1 over 4 to the 2, x to the 2. And why don't we clean that up and call that 16, because that's what 4 to the 2 is. All right. This negative is like just a factor there, and we bring this down, so we have a to the 3 down there, and it leaves a 1 behind. All right, this is a little tricky, but 5 to the -1 is 1 over 5. 6 to the -1 is 1 over 6. Now we need a common denominator. So here we're multiplying by 6, and we get 6 up here. Here we're multiplying by 5, so we get 5 up there, and so this turns into 11 over 30. That's a tricky problem. 8 to the negative 1, we make that positive by bringing that down, so we have 1 over 8 to the positive 1, and you don't write an exponent of 1, so it's just 1 over 8. Now be careful. These problems kind of look the same, and if you're not careful, you do it the same way, but this 4 does not have an exponent on it. So only the x to the second has the exponent, and that's what's moving down. The 4 is staying on the top of the fraction where it originally was, and we're moving this x squared to the bottom of the fraction like that. Okay, now any even exponent gets rid of a negative, because like if you square or you take to the 4th power or the 6th power and you multiply a negative out an even number of times, it goes away. So this is going to go away because this is even, not because it's negative, but because it's even. So it's like a positive a to the negative 4th power, and we're gonna, so like in other words, we have a positive a to the negative 4th power, and then we move that down and we get 1 over positive a to the 4th power. All right, number 45, this is like 1 over 8 minus, this is like 1 over 3, so we have a common denominator of 24. So this one we're multiplying by 3 to get to 24, so we multiply by 3 on top and get that. This one we're multiplying by 8 to get to 24, so we do the same thing to the top and get that. And then we have, when the denominators are the same, they just stay. So 3 minus 8 is negative 5. And that's it. Okay, a common mistake on this would be to divide those 4 out and get 1. But this is a base, and so the base doesn't change. All you're doing is subtracting the exponents. And really, the reason that works is 4 to the 8th is 4 times 4. 4, 5, 6, 7, 8 over 4 to the 6 is 1, 2, 3, 4, 5, 6. And then you're going to cancel. These cancel, 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 and you're left with 4 to the 2nd power. Now you don't have to do all this. This is a little bit silly, but I wanted you to see it once. That's why you get 4 to the 2nd power, or just 16. So remember, when you're multiplying, you're adding your exponents. When you're dividing, you're subtracting your exponents for this reason. So here we have, and by the way, the bases have to be the same because you have to cancel common factors. Right? You can't have cancel a 4 with like a 5. So here the x's are the same, so this is going to be x to the 12 minus 8, or in other words, x to the 4th power. Here we have 1 over r to the 3 power. Now it's true that you go 7 minus 10, that's negative 3, but it said that you have to end up with positive exponents, so this is not okay. You have to write it like this. All right, now this is going to be 6 because the bases are the same to the 4 minus a negative 2. That's 6 to the 4 plus 2, which would be 6 to the 6th power. Here we have, we're going to bring this down, and we're going to have 6 to the 7 minus a negative 3, which is 6 to the 7 plus 3, which is 6 to the 10th power. In other words, we did not bring the 7 up to the top because we would have ended up with a negative 3 minus 7 or a negative 10 up top, and we can only have positive exponents. So we had to bring this down because that's what made the exponent positive. All right, so on this one we're going to bring this up, and we're going to have, this is 7 to the, this is like 7 to the 1. And when we bring this up, it's going to be like a 1 plus a 1, or 7 to the 2. I guess you could leave it like that or put 49. Now, notice that I left these ones in exponential form simply because 6 to the 10th power is such an outrageously large number that it was easier to express it like this. But 7 to the 2, that's easy, so I made it a 49. Okay, when you take an exponent to yet another exponent, you're multiplying, and the reason you're multiplying is really when you take something to the 6th power, you have x to the 3rd times x to the 3rd times 6 times. That's what that means. And now we have x to the 3 plus 3 6 times. Now this is a bunch of silly work. All we need to do, this is going to end up as being x to the, well, this was 6, 1, 2, 3, 4, 5, 6. So that's 18. Now, in the future, I'm not going to show any of this work. I just know that I'm multiplying those. Okay, this is going to be, it's like 3 to the 1 over 5 to the 1. So when I multiply 1 times 3, I get 3. And when I multiply 1 times 3, I get 3. So this is 3 times 3 times 3, or 27. This is 5 times 5 times 5, or 125. So this, I'm going to bring this in, and this is going to be 4 to the third power, t to the third power. 4 to the third is 4 times 4 times 4, which is 64. So that's there. Now, this is going to be a negative times a negative times a negative, which is going to end up being negative. Notice if this were even, that negative would be disappear because you'd have a negative times itself an even number of times. But that's not the case here, so that's going to be a negative. 6 to the third power, x to the 2 times 3 is to the 6th power. And then we're going to simplify this. 6 times 6 is 36, times yet another 6 is 216. So again, this is negative is going to remain negative because we're multiplying it by itself an odd number of times. If this were even, that would go away. So we're going to end up with a negative. We're going to have 4 to the third power, m to the 6th power, over t to the third power. 4 to the third power is 4 times 4, which is 16, times yet one more 4. 16 times 4 is 64. So this will be negative 64 m to the 6 over t to the 3. Now, this negative is going to disappear because we're taking it to the 4th power, so we're multiplying this by itself an even number of times, and that goes away. So we're going to end up with simply a positive. S to the 3 times 4 is 12. T to the 5 times 4 is 20. And that's it. Okay, I'm going to try and fit this all on one page. So here, when I do take care of this, this is 2 times negative 3, which is negative 6. So I have k to the negative 6 times k to the positive 4. Well, it's the same base, so it remains k. And remember, when you're multiplying, you add the exponents. So negative 6 plus 4 is negative 2. But we can't leave our answer with negative exponents. It says that no negative exponents appear in the final result. So we have to bring this down to the other side of the fraction. And if there's no fraction, you create a fraction by putting it over 1. So now we have 1 over k to the positive 2. All right, so now we're going to bring this in, and we're going to have 5 to the 4th power, which is a large number, a to the negative 4th power, times, and we'll bring this in, and we have a to the negative 6. Now 5 to the 4th power is 5 times 5, which is 25, times a third 5, which is 125, times the 4th 5, which is 625. And we're going to have a to the negative 4 plus negative 6 is negative 10. Well, this is not allowed. It has a negative exponent. This does not have a negative exponent, so it stays up on top of the fraction. Remember, there's like an imaginary fraction. And we're moving that factor down, so we're going to end up with 625 over a to the 10. So this is going to become p to the negative 6 over 5p to the 4th. This is not allowed to be in our final answer because it's a negative, and we got to move that down here. And so on the bottom, we're going to have 5p to the 4 times p to the 6, which is 1 over 5p to the 10th. 4 plus 6 is 10. Okay. Here we're going to bring this in, and we're going to get 2 to the 2nd, which is 4, k squared, m to the negative 5 over, and we'll bring this in, we'll have k to the negative 3, m to the negative 3. We're just bringing that in. All right, now, this is not allowed, so we bring that k up, and it's going to combine with this. So we're going to have up on top 4k squared, and then we have k to the 3. And then we're going to bring this down. So we're going to have over m to the positive 5 and m to the negative 3. Okay, so up top we're going to have 4 to the k to the 2 plus 3 is 5. Remember, we're not multiplying these, we're adding them because we're multiplying the bases. So we're adding the exponents. And then this is going to be m to the 5 minus 3 is m to the second. All right. We'll bring this in. We're going to have 2 to the 3, which is 8. P to the 3 over q to the 3 times 2 is 6. Times, this is going to be 3 to the negative 1, p to the negative 4 over q to the positive 5. Because, oops, not positive 5, positive 4. Because negative 4 times negative 1 is positive 4. All right, now, let's see. I'm going to multiply, and I'm going to get, let's see, this 3 is going to move down, and this 4 is going to move down. So what I'm going to end up with is 8p to the third over q to the 6 times 1 over 3, and I'm going to have a q to the 4 and a p to the 4. Okay, now I'm going to cancel. All 3 of these p's cancel with 3 of those, making that a p to the 1. And so I'm going to end up with 8 times 1 is 8. And then I have a 3. We always put our numbers first. And we have a q to the, these are multiplying, so we add the exponents. 6 plus 4 is 10. Okay. Now, here, we're going to take care of this exponent by bringing this in. We're going to have r to the 8th. So what we have so far is negative 4r to the negative 2, r to the positive, oh, I just put negative 8, negative 2, r to the positive 8. And then I'm going to multiply, so I'm going to add these exponents. So I have negative 4r to the negative 2 plus 8 is positive 6. Now, it's a common mistake to try to put this 4 down in the denominator, but this is not an exponent. That's just a negative number. Only negative exponents move to the other side. So that's just our final answer. Okay. Well, I guess I just realized I'm doing these all out of order. I should have been doing them like this. Okay, but anyway, I'm going to bring this negative 1 in, and we're going to have z to the positive 4, x to the negative 3. But the negative 3 is not allowed because it's a negative exponent, so we move that down, and we're going to have z to the 4 remaining on top, but x to the 3 on the bottom. Okay. This is going to be 4 a to the 5th, a to the negative 3 when we bring this in, over a to the positive 4. So I'll bring this down, and we're going to have 4a to the 5 over a to the 4 and a to the 3. Now, this is 4a to the 5 over a to the 7, because 4 plus 3 is 7. Then all 5 of these will cancel out with 5 of those, leaving a 2 down there. So the final answer here is going to be 4 over a to the 2nd. Okay, we're going to bring this in, we're going to have 3 to the negative 1, k to the positive 2 when we multiply that in. On the bottom, we're going to have k to the negative 4. Now, I'm going to bring this up and this down. So let's see, I'm going to have k to the 4, k to the second for that first one, over 3 to the 1 on the second one. And finally, this k will cancel with one of those, making that a k to the 1. So the final answer is going to be 2. We put the 2 first, and it's going to be k to the 5 because 4 plus 1 is 5, all over 3. All right, last thing. I'm going to bring this in. So I'm going to have 3 to the negative 2, a to the positive 8, b to the negative 12 over, let's actually cancel, because I don't want my numbers to get so big on me. I don't want to do a 15 to the second power. That's too big. What I'm going to do is I'm going to erase, and I'm going to cancel before I start doing anything. So this will become a 1 and a 5. Now when I bring the negative 2 in, I'm going to have a to the 8th and b to the negative 12 over 5 to the negative 2, a to the negative 4, b to the positive 8. Now, this b is moving down, this a is moving up, and this 5 to the second is moving up. So I'm going to have 5 to the second, which is going to become 25. I'm going to have a to the 8th, which was there, and another a to the 4 coming up from the bottom, over b to the 8th, which was already there, and a b to the 12th coming down from the top. 5 to the second is 25. A to the 8 and 4 give me 12. And b to the 8 and 12 give me 20. Wow, that was a little bit difficult. But that's it.